Heat pumps and more, planning for a successful electrification. Got some really great speakers for you today, but first I want to thank our sponsors that have helped make this event possible. I'd like to thank two California Energy Commission programs first. That'd be BUILD, the Building Initiative for Low Emissions Development Program, which offers decarbonization incentives for affordable housing new construction, as well as the Equitable Building Decarbonization Program, which offers deep retrofit direct install upgrades for affordable housing as well. So that's for existing buildings. Then also on the existing building side, we have SOMA, Solar and Multifamily Affordable Housing, that offers solar incentives, and LIWIP, the Low Income Weatherization Program, which allows you to access weatherization and energy efficiency upgrades. So thank you again to Build, EBD, SOMA, and LIWIP. If you want to learn more about these programs, feel free to message us. You can email me. My email will be up there as well. Or you could also email sustainability@calhousingpartnership.org, and we'll be able to get you started on these. So a little bit of quick housekeeping. This meeting is being recorded. We do have question and answers down at the bottom here. We will also be doing Q&A at the end instead of throughout the session. So, if we don't answer your questions right away, just know that we'll be getting to it at the end. Should be a little Q&A box down here for the Zoom control panels. So just put your questions in there, and we will get to it. We also have we'll be sending out the PowerPoint deck as well as the recording to participants today. So thank you all for being here. We've got some fantastic speakers. So introducing myself, my name is Ian Sharples. I'm a sustainability program manager with the California Housing Partnership. Joining us today, we also have Kieran Tran, Healthy Homes Organizer from the Asian Pacific Environmental Network, Scott Adler, Senior Associate from the Association of Energy Affordability, Jack Aitchison, Senior Manager for the Association of Energy Affordability, and Erin Keller, Senior Project Manager for TRC Companies. So we'll be diving into decarbonization today. Our agenda will be looking first at decarbonization planning and planning for successful building electrification. Then we'll look at the health benefits of residential electrification, which is something that was requested from last year's session, so I hope you enjoy it. Then we'll be moving on to the more technical side of the program, discussing heat pump decision points, HVAC, water induction, and related measures, as well as some common barriers to decarbonization work and planning responses for how you can overcome them. And then closing out with some maintenance operations and next steps. So what do you do after the equipment has been installed? And then tying it all together with a new construction case study from Build that will highlight some of the items that we've talked about. And then lastly, at the end, we will have Q&A. So again, just put your questions in the Q&A box and we will get to them. So with that, let's get started. So I want to introduce decarbonization planning first, because I think this will frame the entire discussion for not just session one, but session two as well, which is coming on Tuesday. So if you haven't registered for that, be sure to register for it. What do we mean when we mean electrification? So building decarbonization is comprised of four different components. Basically, it means energy efficiency plus electrification plus renewable energy plus a managed energy load. So basically, getting everything to be all electric, then providing that electricity through renewable sources, and then balancing the load across the day so that we're able to best utilize that energy efficiency gains. Some of the benefits for decarbonizing affordable housing, I'm sure you'll hear more about these points in greater depth, but just to introduce the concept, I think there's kind of two big buckets for in terms of benefits, and that's benefits for the communities and benefits for developers. So on the community side, I think mitigating climate change is kind of the obvious one, so we don't really need to dwell there too much, but the more we can decarbonize, the better climate future we'll have for all Californians. Health and safety, reducing indoor air pollution and to help create healthy homes. We know that cooking is linked to respiratory illness, especially in children. So we want to avoid that. And we also know that electricity is not as prone to explosions as natural gas, which is something that I've seen happen here. We also know that by engaging in some of the deep retrofit work that decarbonization programs can help facilitate, this will have an impact on helping to prevent homelessness. We know that currently 1 in 4 California utility customers is energy insecure, and that is a cause of eviction. If you get your utilities shut off because you can't afford that, that can affect your access to housing. We've also seen from recent studies that up to 6% of California's housing or unhoused population lost their housing due to deteriorating building conditions. So if we're able to rehab those properties, we'll be able to extend the usable lifespan and help prevent people from entering homelessness through that avenue. And we also have seen a small but growing risk of climate change related disasters. So think your wildfires. That's at least 1% of the state's unhoused population lost their housing through climate change related disasters. On the developer side, participating in decarbonization work can offer some financial benefits, such as co-leveraging program resources with other financing sources. You're able to access some rebates versus loans, so avoiding um, some debt financing that can, add to your long-term costs. And we've also seen that some of these programs are really good as a gap funding source. So if you are running into trouble with your total financing stack, definitely take a look at some of the programs mentioned today. They may be able to fill some of the gaps for you. We also see long-term savings as a goal of decarbonization work, meaning lower utility bills and ultimately lower maintenance costs. And we also think that it's important for developers to get ahead of changing building codes. So the state is um, trying to move to a goal of carbon neutrality by 2045. And so there's an expected shift in the code from electric ready, which is what is mandated now, to all electric building codes in the future. So if you're able to get those, get ready for that now. That'll save you a lot of time and effort and money in the future when you have to go back and rehab all these buildings to extend their lifespan. So you can see here kind of a timeline of California's climate and electrification policies that are, you know, pushing that shift from all electric ready to all electric that I just mentioned. So as of 2022, there were over 50 local jurisdictions favoring or requiring all electric new construction. So we can see that this is already happening on the local level. Regionally, a number of community choice energy providers and investor-owned utilities do offer 100% carbon-free electricity. So that's something that is growing in popularity. The state has set a goal for by 2030 to have at least 50% of the electricity in the state be coming from renewable energy sources, as well as doubling energy efficiency over, those 2022 levels. And then ultimately by 2045, we're hoping for a 100% zero carbon electricity statewide and statewide carbon neutrality. So you can see there's a pretty clear timeline for when this transition is supposed to be taking place, and we're in the middle of it right now. So a little reminder of what the 2022 Building Energy Code updated, and this took effect on January 1st, 2023. But it encouraged the use of electric heat pump technology. It established electric ready requirements when natural gas is installed. It did expand solar photovoltaic system and battery storage standards, and it did strengthen ventilation standards to improve air quality. So it is important to note that SB 131, which was passed last year, did freeze state and local building code updates through June 2031. So there is a bit more time to get caught up on the 2022 mandates before moving forward, but it's still pretty clear that we're trying to transition to that 100% renewable economy in the pretty near future. I think 2045 will be on us quicker than we realize. So how do we plan for a successful building electrification? First thing you really need to do is do things like you're doing today, which is building staff capacity. So you really need to prioritize the capacity building for your staff. So For new owners to engage in electrification, prioritizing organizational capacity is a real first step for success. And this is really proactive to make sure that you are able to manage those changes that have been outlined by the state over the long term. You can, really improve your staff capacity by taking advantage of comprehensive training programs. So trainings like today, but we also see that there's a number of free courses available for more in-depth trainings on specific technologies from places like PG&E. You can also check out the AEA Electrification Knowledge Database, which is something that you'll be able to access if you take advantage of certain program technical assistance offerings. But you also want to help engage outside expertise, so consider contracting experienced professionals for guidance or complex electrification projects, and explore free technical assistance from programs like Build, which we'll be talking about later today. So definitely take advantage of the resources that are out there to help build your staff capacity, and that'll make the transition to a renewable economy much easier for you. Next, you want to really hone in your use of data and analytics. And this is kind of a self-reinforcing process. So you'll want to look at your data collection methods for energy usage and try to collect as comprehensive data as you can. Then you also want to engage in collaboration with other partners, so either an energy consultant or your technical assistance team to help really dig into what the data is showing you. And then we'll use those insights to help optimize your building performance. And by optimizing your building performance, that'll help maximize the funding opportunities available. So basically, the better data you have, the better you're able to improve the efficiency of your buildings. And by improving the efficiency, you'll open up more decarbonization funding opportunities for yourself. The next really big thing you need to be doing is really prioritizing tenant engagement and education. This is something that the programs have really been putting a lot more emphasis on recently, because we've realized that the better educated tenants are, the better able they are to make the best use of the technology that's being installed. So by empowering your residents with education, they're able to um, make the best choices for themselves and how they're actually operating things. So that'll help mitigate dissatisfaction and energy waste. So, for example, doing a an induction cooktop demonstration. This is a new technology out there that works differently than traditional electric resistant stoves, and even more differently than the natural gas stoves that people may be used to already. So they do need to be kind of shown how those technologies actually work. Explaining as well how heat pump technologies work and kind of the different time frames for how they might heat water or heating and cooling the air can also help mitigate dissatisfaction when people encounter technologies for the first time and they don't work quite the same as how previous technologies that they've used have been working. They're able to, make better use of those. You also need to implement effective engagement. So things like demonstrations, making sure that, educational materials are available in the language of all the residents that are in a building. Um, Trying things like offering childcare or offering some food while educational sessions are going on are all really good best practices. And your TA teams will have will be up to date on some of the best items that you can do. I think we'll see some examples of that later today and on Tuesday. And then lastly, you can help leverage the technology for tenant benefits. So, take advantage of energy monitoring software to give your tenants the best information available on how the new upgrades are working. Some additional considerations before construction. You do need to assess your electric infrastructure needs. So, given the exclusive use of electricity, you need to take a look at what transformers are needed, what switch gears, do you need panel upgrades? Is solar feasible for the space is a really big one. How is your roof configured? Is it able to handle an increased solar load on the roof space? You do need some early consultation. So the earlier you can engage with a technical assistance provider or with an energy consultant, the better able you'll be to put decarbonization measures into your building plans and help avoid costly mistakes. You also want to be utilizing some energy modeling to make sure that the measures you installed all work well together, that you're getting, the savings that you're going for. And last but not least on these considerations, be very proactive with your utility contact. The sooner you can initiate dialogue with your electric utility provider, the sooner they'll be able to put the gears in motion for any upgrades or work that they need to do on their end to be able to actually get the electricity to the building and get you interconnected. So the earlier you're able to get in contact with your utility, letting them know that you're going all electric, um, the less likely you will face costly delays in utility connection. Also, layer incentives, but we'll be talking about that in more depth. So take advantage of the different funding sources that are out there, know which ones you want to pursue, and really integrate that into your building plans. Lastly, I want to leave you with this basic winning formula for decarbonization, which I've shamelessly stolen from other people. Um, but the basic equation that you're looking for when you're doing decarbonization work is switching to heat pumps, adding in solar, adding in storage capacity, and then if you put all those three together, that's when you'll get the big savings on utility and energy costs. So with that, I want to hand it over to Kieran Tran to discuss the health benefits of residential electrification. Take it away.
All right, thank you so much, Ian, for that last section. And yeah, I'll be going into health benefits of residential electrification. My name is Kieran, and I'm the Healthy Homes organizer at Asian Pacific Environmental Network, APEN, which is based all around California, but has deep roots in organizing in Oakland, Richmond, and Los Angeles. Next slide. Yeah, so a little bit about APEN and our work. We're primarily a base building and advocacy organization. We have a base of members, especially immigrant and refugee communities in Laotian refugees in Richmond and Chinese immigrants in Oakland. And most recently, we've expanded to Los Angeles with Asian American communities there. A lot of our work has to do with refinery decommissioning and so mobilizing people against oil refineries. And that has kind of led to our work in building electrification through our community resilience pathway. And so we are part of the California Energy Commission's Equitable Building Decarbonization Program as a community-based organization partner. We also co-lead the community outreach working group. And so we work to recruit other community-based organizations to enroll participants in that program and support with program design. And this is the second big program that we've been on the implementation side of. And so we previously supported SOMA, the solar on multifamily affordable housing units. And yeah, next slide. And so the way that we got involved in this work as a primarily base building organization, then going into program implementation, was that our work really revolves around community resilience in response to refineries. And so when we're organizing people who are already being impacted by their health with the air that they breathe just by living where they live and the environmental justice impacts of that, we're we do have to think about what indoor air pollutants are there if there's already outdoor air pollutants and things impacting their health. Living near a refinery increases risk of cancer, asthma, other illnesses. And so, in addition to that, we think about how do we as a community look into our homes and electrify in order to improve our health, decrease reliance on fossil fuels, prepare for climate change, and also have a just transition from fossil fuels. As Ian mentioned, there's growing policy and advocacy around building electrification and the codes related to buildings in the future. And so, as community members live in older building stock that is highly impacted by gas, at some point when the just the transition happens to electrification in homes, we want to make sure that people aren't left behind and they aren't being burdened with the cost of maintaining the gas infrastructure during those last years of the transition to electrification. Next slide. Yeah, and so some of the in-home exposures that we highlight in our work is first off the indoor air quality, especially related to gas stoves. And so gas stoves are highly linked to childhood asthma through pollutants like nitrogen dioxide, carbon monoxide in the areas that are already being impacted by environmental justice issues. It prevents them from having refuge from outdoor air quality. And so the health implications of that and increased risk of asthma, other respiratory illnesses just from living in areas impacted by pollution, it continues to affect them in their homes. And it's also important to note that one of the reasons why it hasn't been made or tenants haven't been very well educated around this issue is because there aren't really indoor air quality standards comparatively to the outdoor air quality standards and how we define pollution in and outside the home. And then next we have excessive temperature. I think we're trying to move away from just talking about excessive heat and consider more just temperature control as a basic need in the home. Excessive temperatures exacerbate health issues, especially um, illnesses like colds or in communities that are already immunocompromised, so like our elder communities. The number of days that we're having excessive temperatures, like excessive heat, are increasingly happening with climate change, even in areas that have not historically seen high temperatures. And being based in the Bay Area and being on implementation for equitable building decarbonization program in Northern California, we especially see that as an issue up here. And it's also a consideration that based on the climate and climate change that's happening, a lot of older homes or homes that were built in areas like Bay Area, where it's used to more temperatures, may not have already built-in infrastructure for AC and temperature control there. And then lastly, another issue we um, communicate with tenants is mold, which also contributes to respiratory issues. Mold can be an increasing issue in homes, especially because of the climate change and homes not being built with the um, intention of having good ventilation. Outdated HVAC in older building stock is especially an issue. And another consideration that we put into mold and like how prevalent of an issue it is in health and in homes is that in addition to the existing health impacts for respiratory issues and other illnesses that it can cause. It also later requires remediation, which can disqualify units from programs. And so, especially building older building stock, it can benefit from programs like equitable building decarbonization, but mold is such a prevalent and also expensive issue that tenants are oftentimes unable to fix themselves once the issues have already started or when their building is already unprepared to prevent those issues that they can no longer receive help for them later on. And it just creates bigger issues of habitability that make it harder to transition to electrification or other retrofitting in the future. All right, next slide. Yeah, and so these are some examples of the narrative points we use. We, especially since we work a lot with, I do community outreach to enroll people. And so I usually would not be using this this type of numbers and stuff, but this kind of example of the different ways that we link different facts to create the narrative around health and electrification in homes. So these are just a couple of examples of how we phrase different issues around extreme heat, asthma, and gas in homes. Next slide. Yeah. And so, yeah, these are some of the kind of more grounded narrative points that we would use with our communities that we have found to be more well received. And so, yeah, we especially highlight that the health issues are already prevalent in communities impacted by environmental injustice. And that's why it's really important to consider the pollutants in the home and the risks that poses there. Um, the remediation efforts becoming a really big barrier to the just transition, and being able to be reached by state programs that seek to work with low income households, especially. Um, yeah, asthma being identified as a really big example of how respiratory health is impacted by gas in homes. And then, yeah, HVAC is another really big way that we've been able to connect with um, tenants and residents around electrification benefits because a lot of older older building stock are not don't have great HVAC options, don't have great ventilation, don't have AC. And so being able to have control of their indoor temperature and have home comfort, prevent issues like mold are another point that we find to be very well received. Um, and one of our goals with electrification is because the equipment is going to be so energy efficient, it can contribute to um, decrease energy bills and therefore allow more of the household budget to go towards basic needs while still maintaining climate control within their home and not having to make those concessions. We oftentimes reference the heat or eat dilemma where people, especially in winter or if they um, other climates where they have to choose between putting money towards energy bills for climate control, um, or being able to meet their basic needs of food. And that's kind of the crux of what we communicate to tenants and other people who are enrolled to um, try to show them they have more options through electrification. Next slide. Yeah, and with the EBD program, we have a lot of considerations and intersecting issues that we consider in the program design. And so when thinking about building decarbonization, we would also recommend practitioners consider um, energy affordability. There's only so much we can do as, people who are working on the housing side about energy affordability, but especially when in consideration of energy efficient technologies, that could be a way that we can address the affordability issue because electrification will hopefully, in the long run, increase affordability. It may not come immediately to the tenants after electrification, which is a big consideration. Community leadership and also tenant education. A lot of people there's not that much pushback around technologies like heat pumps because the day-to-day changes are not that different. But with things like gas to induction stoves, that's where we see a lot of need for education because that's the biggest change on the side of the tenant, where they'll see changes in having in their own day-to-day life and behavior. Um, and yeah, doing whole home retrofits, including weatherization, so addressing stuff like air leaks, um, energy efficient, new technologies, not just electrification without the consideration of how that's going to impact energy usage. And yeah, other health and safety and quality improvements. I mentioned before how remediation becomes an issue in a lot of programs like building decarbonization because if there are existing habitability issues, it makes it much harder to um, get into homes and improve energy. resilience, and comfort. Um, and yeah, next slide. And so that essentially concludes my presentation about health in homes and ways to connect with tenants, people who are on the ground experiencing those issues. And as community outreach co-lead for the Equitable Building Decarbonization Program, I'm always happy to talk about the opportunities with this program and our learnings from communicating with people about health and other energy benefits of electrification. And so you can reach me there or ask questions during the Q&A. And I'll pass it off to the next presenter.
All right, thank you, Kieran. And then over to Scott and Jack from AEA to discuss some of the more technical aspects of decarbonization. Thank you.
Thanks, Ian. Can you go to the next slide, please? I'm Scott Adler. As was said before, I work at the Association for Energy Affordability, and I provide a lot of technical assistance on multifamily retrofit projects. I'm going to try to make my presentation have a little bit of engagement in it. So if everyone doesn't mind, if you could just put in the chat on a scale of 1 to maybe you're needing some coffee, to 5, you're pumped up and ready to go. Like, how are you feeling this morning? And my presentation is going to be talking about heat pump decision points. So, what are these technologies? How do they work? And what do you need to consider to have a successful project? Next slide, please, Ian. And great, we're seeing sevens, which is even above fives. That's amazing. There are lots of reasons that you've just been told about, and that I'm sure you know about for why you want an efficient and electric building. Building codes are going this way. It's an environmental conscious thing to do. These are safer than having gas combustion in your buildings. It improves indoor air quality, like we just talked about, which is also consequently improves health. It should be a better product. They have cooling, which you maybe didn't have before. We can see utility savings, especially when we're moving from really inefficient systems or electric resistance. And then we also have incentives available right now, which can help tackle those first costs. But just another thing to be aware of for everybody, there are building performance standards coming to California. There's currently just a draft report right now, but these are going to be targeting buildings, large buildings, so if you're greater than 50,000 square feet, and they're going to be setting targets for greenhouse gas and energy use intensity. So decarbonization and energy efficiency. There are going to be penalties for buildings that don't comply, but this is not meant to penalize buildings. It's not meant to be make it harder for affordable housing. There's going to be a lot of support, a lot of incentives, and this is meant to be working together with building owners and with California to make sure everybody can achieve their decarbonization goals. It has a clean pathway there. So just putting this on everybody's radars. Hopefully, this is going to be a helpful tool to accomplish all of our goals. So next question, please. Oh, sorry, next slide, please. And there is a question. So I'm just curious as well from the audience, like where are we at with building decarbonization? How do we feel about this electrification, decarbonization? Just one sentence, one word. Is this something we're all on board with? We're excited about? Is there some confusion still? Um, is it challenging? Pumped? Great. Okay. That's good. But just want to see where everybody is. If there's any people finding this really difficult to do, or if we're all happy with it. And then we can go to the next slide while we get some of those coming in. Okay, then Ian, if you wouldn't mind just clicking slowly, I'm going to show the major technologies I'm going to cover. This is kind of an overview. So the first one is HVAC, so space heating and cooling with electricity. The next one is water heating. So again, just replacing gas water heaters with new electric water heaters. Next one is going to be induction cooking that we're going to be talking about. This is different from electric resistance or electric radiant cooking. And then next we have some renewables that we can pair with our building, so solar PV, batteries. And then finally, there are a lot of other technologies as well, some smaller ones like heat pump dryers. We've got heat pump pool heaters, electric vehicles, which might sound more like transportation, but it's related to buildings, and then electrical upgrades. And one final question just at the start while everybody is so engaged, which is great. I just want to know where the audience is at in terms of your um, level of understanding of all of this stuff. Are you an expert? Do you do this every single day? Is this the first time you've seen this? Or are you somewhere in between? So again, just a quick 1 to 5, if you don't mind, one being you're newer and five being you've seen all of this and I will try to cater it to you. I will just go over though what is a heat pump first, just because I still think this is confusing. And a heat pump is something that moves energy, so it uses electricity to move heat from a colder to a warmer location. And the good thing is we all know what heat pumps are and we all use them every day because our refrigerators, as we know, are heat pumps. They move heat from a cold location, which is inside the refrigerator, to a warm location, which is outside of the refrigerator. And just for fun, this will be the most technical thing we do, but we're going to go through the refrigerant cycle really quickly. It's this 1, 2, 3, 4 thing on the diagram here. So we have a refrigerant at one here, and it's very, very hot, this refrigerant. It's hotter than the ambient space, so it's able to give heat to the space. So at one, we have a hot refrigerant, and it gives off heat to a space. Then as we go clockwise around to about 12 o'clock at 2, we go through an expansion valve, which allows the refrigerant to expand and rapidly cool, and then we get a really, really cold refrigerant. If we continue going around the space, now we have a really cold refrigerant in a colder environment, but since the refrigerant's so cold, it can still absorb heat from that cold environment. So um, it takes in some heat and it becomes a little less cold, how it's light blue. Then at 4, I saw at the bottom there, it goes through a compressor, which compresses that refrigerant and makes it really hot. And then we're back to the start where we started with the cycle at 1 with this really hot refrigerant. So throughout this cycle, the really cool thing that happens is in the colder environment, we're able to um, take in heat from the surrounding. And then in the warm environment, we're able to push heat into wherever we're trying to put it. So, for example, if we're trying to heat a space, we can take heat out of a colder outdoors and we can put heat into warmer indoors. The great thing about this as well is that this was a heating cycle we just went through, but you can just switch the direction of this and create a cooling cycle. So you can have both heating and cooling with the same piece of equipment. The refrigerator is kind of doing the cooling cycle, and the AC would be doing the cooling cycle. It's making a space colder. And then if you wanted space heating, or on the right here, there's water heating. Um, that is doing a heating cycle. So it's taking heat out of the air and putting it into something like hot water to give you hot water. Next slide, please, Ian. And thank you everybody for putting so much in the chat. This is really great to see and a little distracting, but I've read most of it. So a quick question is, what is the difference between a heat pump and electric resistance? They both use electricity. Why is one maybe better than the other? And this is all about how heat pumps use refrigerant to move heat rather than directly generating it like electric resistance does. This is great because it allows heat pumps to be 3 or more times as efficient as electric resistance. And electric resistance, this is just your electric resistant baseboard. Maybe you have a plug-in space heater for your office that does electric resistance. It's those kind of things. And this is great because if we're 3 times as efficient, that means we're using only a third of the energy. This can save a lot of energy and consequently a lot of money, especially in California where we have these high electricity rates. And another really cool thing is if we're using less electricity to get the same amount of heating or cooling out, then we can sometimes get these systems installed in buildings where we don't have the capacity to put in big electric resistance systems because they take less breaker space, they draw less power. We can install them in a lot of our existing buildings. And I talked about this again, but I'll just mention it once more. We can just reverse this and we can get cooling. Electric resistance, you can't reverse the direction of electricity and all of a sudden get cooling out of your electric resistance heater. It just does heating, whereas heat pumps can do heating and cooling. Next slide, please, Ian. So we'll move now to heat pump HVAC, which we've already talked a little about. And the point of the slide is just to let you know there are tons of products out there and tons of solutions for whatever building configuration you might have. There are mini split systems, which people are probably familiar with. It's where there's a outdoor unit that creates hot or cold refrigerant, sends that inside to the indoor unit, which will blow that heating or cooling into the space. That's in the bottom left photo there. Then in the top left photo, there's a ducted split system. This is very similar to the mini split system, except instead of blowing air directly into a space, it first puts it into ductwork, which distributes it all around the apartment. Then they can be kind of an all-in-one system. So instead of having that split where you have that outdoor unit and that indoor unit, it can sometimes all be together in a package system, which is the bottom right photo there. These are usually connected to ductwork and can distribute the heating and cooling throughout the building. Then I'm sure we've all seen through the wall systems, which is the top right there. These are really common in motels, hotels, underneath the window there. So these kind of split outside and inside to do heating and cooling. A newer technology that's coming to the market is a window or room heat pumps, and they have a lot of opportunity to be scaled because they can often be plugged into 120-volt circuits. There are some that can be DIY installed, so they have an opportunity to really bring down costs. And then finally, I don't have a photo here, but there are larger central variable refrigerant flow systems that you can use for larger buildings. So we talked about it already. Heat pumps can do heating and cooling, which is great. Another big advantage over gas systems is that you're removing that pollution that you're getting from gas. And then secondly, a lot of these systems have great filters on them. They can do ventilation only mode. So you can really improve the indoor air quality with these systems. Next slide. Water heating, story is pretty similar. There are lots of different form factors that exist out there to try to help you install these systems depending on what you currently have. So the most basic is just an integrated tank. That's the top left photo here. It looks pretty similar to what a tank type gas water heater might look like. The heat pump technology is up top where the ducts are coming in and out. So that's how it's taking heat from the air. And then it puts that heat into the water, which is just the bottom half or bottom probably three-quarters of the tank there. There are also split systems, which you can think of really similar to the mini split systems, where there's an outdoor unit that's creating hot water or hot refrigerant, and then it sends that inside to where you just have a tank, and then you just have a tank full of water, which is being heated from that outdoor unit. You can also have central systems. The photo here is a skidded system, so it's all in one. You've got your water heaters creating heat, and then on the inside, you've got those big tanks storing that heat. But you can also have systems with bigger heat pumps as well and kind of make it custom. One consideration for heat pump water heating is that heat pumps generally create hot water at a slower rate than gas systems do. Because of that, they often need larger storage volumes, and that consequently makes them a little bigger and weigh a little more. So when you are doing a retrofit or when you are installing this equipment, it's important to know that they often need a little more room, and that might affect the location of where you put them. They also do not really support tankless applications at this time, which is a question or something people love about gas tankless water heaters is that they have such a small footprint, but typically they don't support that application. A cool thing though about having to have this extra storage volume is that you can really take advantage of differences in electricity rates. You can charge that hot water when electricity rates are cheap, and then you can be using that hot water in higher electricity rates and get some bill savings there. Next slide, please, Ian. So a little case study just on equipment location. It's really a challenge, and this is just an example of one solution for this problem. So retrofits, they can require more electrical capacity than was existing. They could initially be in tight spaces and need bigger spaces. They definitely need ventilation because these technologies extract heat from something, typically the air. Structurally, they might require some engineering because you might be adding equipment, you might be adding weight to a space, and then you often want to consider noise and sound as well, because these are like refrigerators, they have a compressor, a fan, they're humming, they make a little bit of noise. So in this situation, on the left photo here, you can see the existing equipment. There were gas tanks. This was a building in Fresno. I think it was built in the 1990s for about 53 apartments. And this small room with these small water heaters was serving the building. The new equipment was going to be bigger. It wasn't going to fit in there. It needed electrical, and there was insufficient electrical to this space. This was on the second floor, and it was just wood construction, so the added weight and volume of everything would not have worked. It needs ventilation, and there was no ventilation in this space. So the solution here, and again, this is just one solution, buildings are unique, and there are a ton of different solutions out there, was to drop a skidded system outside of the building, right by an electrical panel. Had plenty of ventilation. Structurally was great because it was on the ground, just on a concrete pad. And in terms of noise, it was far enough away from residents' windows to not be an issue. Next slide, Ian. Great. So back to technologies now. Induction cooking. Induction cooking transfers heat directly to your induction compatible cookware using an electromagnetic field, which means your induction compatible cookware has to be magnetic for it to heat up. The great thing about induction cooking is it puts the heat directly into your pan rather than an intermediary like a flame or a resistance coil. So it transfers everything, the heat more efficiently. It also is really fast because of this, the direct transfer. So it heats water, boils water faster than gas does, faster than electric resistance does. And because of this, it's a lot safer as well. There's just your pan that gets hot. The surface stays relatively cold. It will only heat up indirectly from your pan going back into the surface. If people haven't used induction before, I highly recommend it. It's really cool to see just how fast it works. And a lot of utilities have loaner programs. For example, PG&E is an induction cooktop loaner program. Next slide. So solar PV and batteries are great to pair with electrification. If you electrify your heating, your water heating, your cooking, then you're using a lot more electricity. And a great way to save on utility costs is to install PV and be using the electricity you're generating directly in your building. Batteries are also great solutions, especially if you're somewhere where you have power outages. They can add resilience, but also you can be charging these during off-peak hours and then discharging them during peak hours to again protect yourself from high electricity rates in California. Next slide. And then finally, I'm going to talk about EVs, EV chargers, and electrical upgrades. And one final question in the chat, just because we all love electrical infrastructure upgrades. What are some electrical infrastructure challenges you might have run into? You can just list one or two things. You don't have to give me an essay if it is very, very long. But EVs, why are we talking about them? Electric vehicles decarbonize transportation, but we need to charge these electric vehicles. And vehicles are generally sitting at our house. So we want to be charging them in our homes. We need chargers in our homes. If we're talking about low income or affordable housing, not everybody has an EV right now, but California will be requiring only the sale of EVs after 2030, which means the secondhand market for EVs is going to increase. Hopefully, EV prices will continue to decrease. And basically, in California, everybody is going to be driving EVs eventually. So we need to be planning for this in our buildings. Electrical upgrades are required. Sometimes we cannot get around them, but two great strategies to try to minimize them are first, power efficient design. So whenever we can be smart about what we put in using efficient equipment, we can decrease the electrical capacity we need. And then another thing we can do is if we do have too much electrical capacity, or sorry, if our loads are greater than our building's electrical capacity, there are some smart load management strategies we can use to not allow simultaneous operation of things that don't need to operate simultaneously to keep our building's electrical below what is to keep it below the maximum it can see. The next slide, please. Okay, and a mini case study here. I don't know if this is going to answer any of the electrical challenges that were put in the chat, but load monitoring can also be a great strategy. So understanding what your existing building is really using. This was how we're able to electrify this building, which was almost 100 years old. We're able to see, well, what is it you're really using by installing load monitoring, then working with the budget of what is available and using really power efficient design. So here we were able to use 120 volt plug-in through the wall package terminal heat pumps. And these were really uh, effective to install from an electrical capacity standpoint. And they also made for a really low cost installation because they could just simply be plugged into a shared circuit. Next slide. And a few more slides just on some considerations before I wrap up. Next slide. Energy efficiency, like Ian mentioned, is also really important, and we cannot forget about this. We first want to do the fundamentals, decrease the loads in the building, put in insulation, and then that will allow us to install smaller systems for heating, cooling, water heating. That's great because it just decreases how much energy we're using in general. And then also, if we're installing solar at the end, that can cover even more of our utility costs. So electrification is great and we need to be thinking about it, but we also can't forget that energy efficiency is a really easy thing to do and an important thing to do to decrease our building electrical loads. Next slide. The resident experience, which has also been touched on a little, is also very important. These pieces of equipment are better performing than the existing gas equipment, but if you don't get trained on how to use it, it might not perform that well for you, or you might not enjoy it. Some questions we often get are people saying, why is my electricity bill higher? And it typically does increase if you switch from gas to electric. Your electricity, you use more electricity and it increases. But it's important to also look at what was your gas bill, how did that decrease? And we often see neutrality between those two. There are also typically programs that you can participate in with the new electric equipment, which can bring down electricity costs even more. People might notice new noises with electrification technologies. This is just because compressors make hums similar to your refrigerator. It's important to let tenants know if they have a new water heater that's a heat pump water heater, it is going to make a noise. That's totally normal. And also maybe not to install that somewhere where it's going to be disturbing, like near someone's bedroom. And then with induction cooking, we talked about this a little, but pots and pans that you could have had may no longer work with induction cooking. So we usually see, but a lot do, just to say that quickly, cast iron, stainless steel, anything that's magnetic will still work. But it's often a good idea to provide residents with induction compatible cookware just to make sure they get off on the right foot using their new induction appliance. Next slide. Okay, this is my final slide. Sometimes there's a question, which is, what is better, unitary equipment or central equipment? Multifamily buildings can have both, or sometimes the systems are split. Water heating could be central, space heating could be unitary. And for a retrofit, the answer is typically to just match the system. If you have a central system, go to an electric central system. But there can be some reasons to switch. Um, if you have a really bad distribution system, which needs a lot of repairs and will be very expensive to repair, it might be worth looking into swapping from central to unitary. Sometimes you might have limited space to locate central equipment. If you need a whole bunch more storage for that new water heating system, maybe you can't put that on the roof. There's no room for that new equipment. So you might have to relocate that, or it might make sense to look at if unitary systems might work. And then a reason why there is often a push to moving to unitary equipment is just because it puts the cost on the resident and that encourages conservation of energy because you're directly seeing the costs. Um, you might also want to switch from unitary to central, and some reasons for that is that sometimes it's more cost effective for central equipment. You just have buy one big piece of equipment and maintain one big piece of equipment rather than having to buy maybe hundreds of smaller pieces of equipment for hundreds of apartments. Also, if you might not have space similar to central in the unitary application, so you might have to move something outside or maybe centralizing it makes sense. And then residents are always going to love you if you move to a central system because you open up more storage space for them and just get equipment out of their homes. I'm not going to talk on this, but obviously, if you're changing from owner paid to tenant paid utilities or vice versa, this will impact utility allowances. So that's something to really consider if you do this. And I think I ran over a little, but I'm going to pass it to Jack now.
Thank you, Scott.
Awesome. Thanks, Scott. Hi, everybody. My name is Jack Aitchison. I am also with the Association for Energy Affordability, and I'll be discussing common barriers and planning responses for your electrification project or portfolio. Next slide, please. So I'm sure that was a lot to digest from Scott. There's a lot of different moving parts when you are electrifying a multifamily building. And so where to begin, whether that's an individual building or a portfolio. Next slide. We would recommend submitting an interest form. These programs listed here, the low income weatherization program, the PG&E multifamily single point of contact, these programs have technical assistance aspects. There's also other programs that exist that have technical assistance aspects. The Bay Area Multifamily Building Enhancement Program, the Tri-County Regional Energy Network Multifamily Program, the Comprehensive Affordable Multifamily Retrofit Program. There are tons of programs out there where you get a technical assistance provider like Scott, like myself, that can help you do individual project planning and also portfolio planning. Next slide. Beyond just planning support, assistance is necessary because there is a lot of different programs that exist in California, and the landscape is confusing. There's different eligibility requirements. Some require different geographical area, or some serve different geographical areas. Some serve low-income affordable housing only. Depending on the number of stories, you may be eligible for a program or not. Programs also provide funding for different measures: energy efficiency, electrification, solar PV. As Scott mentioned, and Ian mentioned as well, sometimes you want to pair all of these things together. So are you layering multiple programs to improve energy efficiency, electrify, and add solar to your building? Programs also have different timelines, different funding cycles. There's rules around co-leveraging, which programs can be leveraged together, which programs can't. How do you prepare for rebates? And then in addition to that, which this is just one item here, but scoping and troubleshooting support. So during the actual construction of your project, you have a technical assistance provider that can help you troubleshoot issues that have arisen from your electrification project, and also help support scoping. So technical assistance is free. It's really the best way to get started. Next slide, please. And beyond just, like I mentioned, your individual project, technical assistance can also provide portfolio and planning support. You may have a lot of different buildings in your portfolio and you're not really sure where to start. You can submit your portfolio to a program like the Low Income Weatherization Program, and you'll have a TA that's assigned that will go through your portfolio, understand the needs of each project, and determine sort of a priority list based off of what your priorities are. What do you want to tackle first? Is it an easy project to get your feet wet? Is it the project that doesn't have heating working properly right now, and we want to tackle that first? So it really depends, and technical assistance is here to help. Next slide, please. Typical multifamily retrofit process. So typically the first 1 to 2 months is the property owner, PO in this case, submits an intake application form, confirms that the project is eligible for the program, or portfolio is eligible for the program. You get assigned a technical assistance person like myself or Scott, and then you start with an initial scope call. This is also a time, if you submit a portfolio, to go through your portfolio of projects and sort of make a priority list. And then you move on to a site visit, identifying measure opportunities, estimate savings and incentives. This is also a time for your technical assistance provider to identify additional programs. So if you enroll in one program, let's say the Low Income Weatherization Program, and they provide great funding, usually around 50% of the cost of the measures, but you really don't have enough reserves. I mean, a lot of affordable housing doesn't have much reserves just sitting in a bank account there. The LIWIP technical assistance provider can help identify additional programs that can be layered to help make it a cost-covered project. Finalize scope, identify electrical upgrades required. So this is really finalizing what all needs to be upgraded in order to support your electrification and energy efficiency project. Help solicit contractor bids, reserve the incentive. Now, this is not the case for every program, but most programs, we have a process where we reserve the incentive when you commit to construction. That basically means we set aside that money so that another project can't swoop out from underneath you and take that funding while you're in construction. That funding is reserved for you. And as long as you meet the minimum performance requirements and complete the project, you will receive that funding. And then there's, of course, the construction period, post-installation inspection, and incentive payment. So all in all, for an electrification project, that's a 12 to 24-month process. It takes time. It takes time to identify additional funding. It takes time to scope out these complex electrification projects. So just want to set some expectations there. Next slide, please. Incentive program payments often come in at the end of the project. Even if a project is cost covered, that payment will come at the end of the project after completion. So cash flow can be an issue. Some programs are able to pay 25% upfront. Some programs are able to pay 50% payment once the contractor orders materials. Some programs allow for 80 to 90% payment while you're waiting for permits. That can be a very common thing where the project is complete, it meets all of our requirements, except for the permit is yet to be closed, and you're waiting on the building department to come out and inspect the property. So there's also options around phasing. You can do building by building. You can do measure by measure. It's a way to sort of, it creates a longer project, but it's a way to help support cash flow issues. Next slide, please. So the next portion of my presentation is going to be talking about common technical barriers. We now understand, like, how do you plan for your electrification retrofit? You sign up for technical assistance through one of those programs, but now you're in the nitty-gritty of your project. And I'm going to be covering some of the technical barriers associated with electrification. And then I also have like mini case studies associated with each of these, except for lack of contractor knowledge. But going down the list, space constraints. This is very common for water heating electrification. Heat pump water heaters are just generally larger, and I'll talk more about that. Historical preservation. A lot of our affordable housing properties are older building stock, and they have more complex requirements with not being able to adjust the facade because it's a historic building. And so there's some considerations there, and also a case study. Electrical constraints for added electrical loads. When you're electrifying a building, you're adding electrical load. So do you have the capacity to support those loads? And then condensate management for new condensing appliances. Heat pumps create a condensate, and that condensate has to be drained to a drain somewhere in the unit, and that can be challenging. And so I have a case study around that as well. And then, of course, lack of contractor knowledge. The electrification world is always changing. Even though heat pumps have been around forever, and it's the same technology as your refrigerator, there are new technologies like different heat pump water heaters, different heat pump HVACs that are arising constantly in the electrification space. So contractors are often not always in the weeds on that as well. Next slide, please. Alrighty, so space-constrained heat pump water heater installs. Heat pump water heaters require larger tanks than standard gas water heaters. That's because they are taking heat from the surrounding air and dumping it into the water. That process takes a lot longer than compared to a gas water heater that basically just like torches the water and heats it really quickly. Now, as Scott mentioned, even though that process is a little bit longer, it's significantly more efficient. Not only do they need space because they have a larger storage tank, because that process to heat water takes longer, they also need a lot of free air to work effectively, preferably warm air. So typical locations where we see water heaters, we see garages or water heaters located in garages. This is super uncommon for a multifamily building. I think I have been to plenty of multifamily buildings over the 10 years I've worked as a technical assistance provider. And I think I have seen one multifamily property where we had individual garages for each dwelling unit with a water heater located in it. And I was like, look at that. It's like the first time I've ever seen that. So it's super uncommon. Space is a premium in multifamily buildings. So oftentimes we are seeing water heaters located in outdoor closets and indoor closets. And when the building was built, we're not building those closets out to be super large. Typically, we're seeing them as small as 24 inches wide. That's like on the smaller end. And space is at a premium. We often don't have room to expand that closet in our multifamily building. Next slide, please. So like I mentioned, heat pump water heaters also require fresh air. So our closets are going to be small, typically in a multifamily building. We also need to make sure that we have enough air changes, enough circulation in that closet. One of the ways that we can do that is through louvers. You can see those the photos here where we have basically vents for the heat pump water heaters. One thing to note here is the exhaust air is cold, so you have to be considerate of that, especially in an indoor installation. When you are working with a contractor, you want to work with a contractor that is open to using different manufacturers. Different heat pumps have different orientations of where the air goes into the heat pump and where the air leaves the heat pump, so intake and exhaust. A technical assistance provider will be able to tell you which brand of heat pump water heater may be a better fit just to avoid clearance issues. Like you can see this Bradford White heat pump water heater here. The exhaust is on the back of the unit, directly on that back wall. There's not that much space there. Maybe we should have gone with a different heat pump water heater that has a little bit more clearance and has that vent for the exhaust in a different orientation. And there are a lot of different options and variations to solve for different space constraints. Next slide, please. And now I have a small closet case study. This is like a mini case study, similar to the ones that Scott shared, but this is a 10-unit affordable housing garden style property, 3-bed, 2-bath, 4-bed, and 3-bath units serving low-income families. So we're in a pretty densely occupied unit and also larger units. I mean, 3-bed and 4-bed units for multifamily building is pretty much as large as you get. And the scope of work included gas cooking to induction ranges, gas water heaters to heat pump water heaters, gas wall furnaces to heat pump mini splits, low flow aerators and shower heads, and LED lighting. Next slide, please. So we're going to focus on the water heating, and we're going to focus on sort of the space constrained installation of these water heaters. So the existing water heater is 40 gallons, 18 inches in diameter. That's extremely small. And like I mentioned, most heat pump water heaters are going to be larger because the process of heating that water takes a little bit longer. So we want more storage volume to make sure that we don't run out of hot water. The water heater closet was 24 inches wide. Again, like probably on our the smallest size of closet that we typically see in a multifamily building. There's a small amount of existing ventilation, but we had to add more. And the new heat pump water heater that was installed was 50 gallons, about 22.25 inch in diameter. The larger heat pump water heaters, like the 80 gallons, those can get up to around 28 inches in diameter. And you're likely looking at a 30-inch wide closet to fit those in. But we were able to just barely squeeze this 50-gallon water heater into this location. One of the things that we did while we were speccing out this project was making sure that we were selecting a heat pump water heater that had water connections on the top. Sometimes they have them on the side. I mean, we have very, very small amount of clearance on either side of this water heater, so we had to have top connections. We also selected a water heater that had the exhaust in a place that we could orient it so that it faces the louver here so that it can get proper ventilation. We also included a mixing valve. What a mixing valve allows us to do is sort of store water at a hotter temperature, which effectively increases the storage volume. If you can imagine, the water heater is storing water at 130 degrees. You're using water at your tap at 105 degrees. Cold water is mixing with that hot water to deliver 105 at the tap. And that really is a way to sort of expand or increase the effective storage volume without actually increasing the footprint. Now, I will say, with technical assistance, you have someone that is helping you support with all of these decision points and all of these considerations, but we're not perfect. In this example here, the bathroom was just on the other side of this wall. And what was happening was tenants were taking a shower, and then the heat pump water heater would kick on and would be blowing cold air onto the tenant as they left the bathroom after taking a shower. So these are the types of things that you may not think about prior to your project, but you will think about it in the next project. And that's what really the benefit of technical assistance is. You have someone that is learning from experience doing these types of retrofits that is on your project team that can help you think of these considerations and learn from the mistakes that they had previously. And so it's a really great way to make your project as effective as possible. Next slide, please. Uh, as we start to see more emerging technology out there, we're starting to see more solutions for some of these technical barriers. For example, here we're seeing more and more heat pump water heaters that are coming in this form factor where we have a tank and a heat pump that kind of looks like a mini split heat pump on the that goes to the in the outside or goes outside. And you'll have refrigerant piping or maybe water piping piped in between. But this is a great way for electrifying your water heating when you have really, really tight spaces. You just have to install the tank inside that interior closet or exterior closet. And there's no ventilation necessary. There's no clearance issues, really. I mean, it's basically just a tank, which makes it a lot easier to solve for some of these space constrained heat pump water heating electrification projects. This is also a great option if you have like the electric resistance low boy water heaters, like the 30-gallon or 20-gallon electric water heaters that sit under a counter. These heat pump water heaters, the tanks, they will work for most counters or some counters, but not all. But still, it's an option. And as technology is advancing, there are more options to solve for these types of technical barriers. Next slide, please. Heat pumps in historic buildings. We see this all the time, like I mentioned. Affordable housing is typically our older building stock. And our older buildings are going to have typically hydronic systems or steam systems. These are central systems that are sending hot water throughout the building to radiators, either like at 150 degree or 140 degree water or much hotter water that is steam. And our retrofit options here are for the hydronic system, you can actually pull out your hydronic boiler and replace it with a heat pump chiller. Now, what a heat pump chiller does is it operates like a chiller, if you're familiar with a chiller, but it can reverse its cycle and provide hot water to those radiators rather than just cold water. And you can see this here on the photos on the right. This is a gas boiler serving radiators in a multifamily building. And that was pretty much a drop-in replacement with this heat pump chiller. So we were able to remove that gas boiler, put in this heat pump chiller, and keep the same radiators in the unit. Now, of course, there were lots of challenges here because we had to move the heat pump chiller to the roof. So there's some repiping. But in terms of like electrification of an old historic building, these are some of the easiest retrofits. For steam systems, it's a little bit harder. There is no like drop-in replacement steam heat pump water heater. And so your options are a variable refrigerant flow heat pump, which is Scott touched on this a bit, but this is basically a commercial heat pump HVAC system that sends refrigerant all throughout the building. The variable refrigerant piece allows you to heat one zone and cool another zone, which is great. We often see these in commercial systems, but it's pretty costly of a retrofit. It's going to require a lot of refrigerant piping. You're probably going to be opening up walls. Another option for a steam system is the 120 volt room package thermal heat pumps. When I say 120 volt, this really means that we can like plug them in a general outlet. Now, in some cases and in some jurisdictions, even though that outlet has enough electrical capacity for that package thermal heat pump, you still may need to run a dedicated circuit because it's considered the permanent heat source. But it is a great option. It significantly reduces the need for electrical upgrades. And one of the big characteristics or considerations around these package thermal heat pumps is like any heat pump, it needs access to the outside air. So you may be making facade alterations. And that is something that needs to be coordinated with the planning department. Lastly, our historic buildings, we often have a lot of space constraints. Historic buildings, space is at a premium, and so that's another big consideration we need to make while electrifying those older buildings. Next slide, please. So here's a case study of heat pumps in a historic building. We have a 31 dwelling unit property, rehabbed in 1959, but built in the 1800s. I never really got an exact date of which this building was built. It was rehabbed several times. At one point, it was a factory, then it was a hotel. Regardless, it is now a multifamily building, and it was rehabbed under the Bambi program between 2018 and 2022. COVID was thrown in there, so that's a much longer project timeline than what a standard project would take nowadays. But the existing heating at this property were gas wall furnaces. So a little bit unique. I mean, I haven't really seen that many wall furnaces in a historic building. But regardless, we removed those wall furnaces, installed these 120 volt packaged heat pumps. And you can see the photo on the right. These are the little vents that were installed to have this heat pump access the outdoor air and provide heating and cooling to the space. Now, there was a lot of back and forth with the planning department for this project. And, a lot of planning departments may not approve this type of retrofit because they want to maintain the existing facade of the building. But some planning departments do, and that's some of the experience that you get from support from a technical assistance provider, knowing what might be approved in one jurisdiction and what might not be approved in the other. Other measures that were completed at this project include attic insulation, recirculation pump controls, pipe insulation, electrical upgrades, refrigerators, and lighting. This just, on all of our projects, and you probably have seen this with the previous case study, we're always trying to pair electrification with energy efficiency. Next slide, please. Another common barrier is electrical constraints. On the equipment side or the new equipment side, there are a lot of 120 volt options available. And as a reminder, those are the type of electric appliances that can plug into an existing outlet. And again, some of these need a dedicated circuit. For example, this heat pump HVAC here in the middle, that typically needs a dedicated circuit because it's your primary heating source. But in a lot of buildings, or maybe in some jurisdictions, it will be allowed to just be plugged into a circuit. This stove here on the top right, that's a battery backup stove. That's a full induction range that basically plugs into a shared circuit, plugs into any outlet, and it charges the battery while you're not using it, and then dissipates that battery, providing you full induction cooking power when you are using that oven. So there's a lot of great technology out there to help support and avoid costly electrical upgrades. If you're not interested in a battery, the one below is 120 volt full induction range. This requires a dedicated circuit, but only 20 amps. So very, very small. I mean, that's the same amount of power you get from your garbage disposal, or is required for your garbage disposal. For water heaters, there are 120 volt options available as well. These can be plugged into an outlet. Really, when we talk about electrical constraints, one of the big things that people bring up are capacity. I'll talk a little bit more about that in the next slide. My breaker spaces are completely full. You can see here that in this panel here, there's these mini breakers. Oftentimes, even if the panel is full, you can install multiple mini breakers to free up breaker space for electrification. And then really our biggest sort of challenging factor for electrification in terms of existing electrical infrastructure is recalled electrical panels. So you have that Zinsco panel down here. These are a fire risk. There's also Federal Pacific. There's a few others that have been recalled, and we may need to upgrade those, not to increase capacity, but just to remove that fire risk. And we don't want to be adding circuits to something that is outdated and recalled. So that's really a big challenge there. But ultimately, a lot of building owners are happy to remove that from their property. There's probably some savings associated with insurance premiums when you remove that Zinsco equipment. Next slide, please. So talking about capacity, there is a way that you can calculate your load using the National Electrical Code. You plug in how many appliances you have, you plug in the square footage of your unit, and it spits out how much electrical capacity you require in amps. What we found is that significantly overestimates the actual peak amp draw. And the electrical code actually allows you to use monitoring data rather than that calculated required capacity to determine what your existing usage is. And we can see that kind of here. There's a study done where they monitored 22,442 California homes. So these are single family homes. And what we found was that around 48% of them, their peak electric draw was less than 30 amps. And so when you hear a lot of people talk about electrification, there's a lot of people talking about how we need to upgrade every dwelling unit to 150 amps. We need to upgrade every single family home to 200 amps. When in reality, if we just are more critical about what existing capacity we have, using this sort of like monitoring option, we can electrify a whole bunch of end uses without upgrading or increasing capacity. And that's really, really powerful. Next slide, please. And here we have a case study talking about electrical monitoring. This is similar to the one that Scott shared, but a little bit different. This is a 24-unit apartment building, 16 one beds, 1 bath, 8 2-beds, 1 bath. Every unit includes a balcony. Built in 1998, the property has 2 buildings, each with the 400 amp service. Now that's quite a lot of capacity. I mean, we could, just like calculating the load, we could probably electrify all of the end uses in this site, but maybe not. Resident profile, adults with developmental disabilities with incomes up to 50% of the area median income. Scope of work included ducted furnaces, ducted heat pumps for 2-bed, replaced with ducted heat pumps for 2-bed units, and wall furnaces replaced with ductless heat pumps for 1-bed units. Next slide, please. So since this was a grant-funded project, we were able to monitor the electrical load pre and post retrofit. And so you can see here in this first column, NEC deemed calculation. This is basically the result of calculating the existing electrical load based off of the calculator that is in the electrical code. And we're seeing for building A, 243 amps, for building B, 315 amps, still quite a bit of capacity compared to the 400 amp service. But if we compare that to what we actually monitored, we were seeing only 41 amps for building A and only 30 amps for building B. If we have that much available electrical capacity, we can pretty much electrify everything in this building. We can add EV chargers. This is a really great way and a great tool to maximize your available capacity and avoid costly electrical upgrades. And then on the post retrofit, this sort of ties into how efficient these heat pumps are. You can see we saw a slight increase for the calculated load, about 40 to 50 amps for each, but the actual increase measured was only 3.5 amps for building A and only 16 amps for building B. So a significant reduction compared to the calculated load. And this is a process that we use all the time in our projects, and technical assistants can help you plan for this type of monitoring to avoid your costly electrical upgrades. Next slide, please. All right, now I have a heat pump water heater condensate management case study. This is an example of probably like extreme condensate management. Typically, properties, we usually have a way to manage that condensate or drain that condensate to a drain. But this was a low-rise building, 82-unit property, so a large property, serving low-income families, larger units, mix of 3 and 4 bedrooms. Typically, a property this size, we would have a central system, for water heating, but in this case, we had an in-unit system. We had limited space for mechanical equipment in the unit. Space is at a premium, like for most affordable housing. The existing water heaters were not installed to code. So this is really why it was so difficult to manage the condensate in these in this property. So typically for any water heater, electric, gas, heat pump water heater, you have a drain pan. And that drain pan has to be piped. It's basically a way to like collect water if that tank starts to leak. And there needs to be a drain in that drain pan to tailpiece, some way to manage and sort of direct that water out of the unit. Well, there was no drain pan at this property, and there's no clear access to a drain from the water heater closet. And the property had water damage from previous gas water heaters leaking. The scope of work included induction range, HVAC upgrades, gas water heaters to heat pump water heaters, LED lighting, and low flows. Next slide, please. So this is like as technical as I'll get, but it was a very, very complex retrofit to manage that condensate and dispose of that condensate. So this is a floor plan of the unit, and you can see where the water heater is. It's in this closet in the hallway, sort of island away from any exterior walls. And the bathroom was like on the other side of a hallway, so there's no clear way to get to the bathroom. Um, this was also located in LA and pretty much like on a concrete island. Like around the building, there was very, very limited plants, very limited greenery that we can like dispose the condensate to. So there wasn't an option to sort of like run it to the outside. It would just be dripping on concrete, which the building department wouldn't approve of. So what we ended up doing is we ended up using a condensate pump to pump the condensate up into the ceiling here, where there was the heat pump for HVAC. And we actually connected the water heater's condensate to the heat pump's condensate, and that was all drained down to that bathroom faucet drain. And so really, this is like as extreme as it gets in terms of condensate management. Typically, we have, if the property was built to code, we would have had an easy way to route that condensate, but unfortunately in this case, that was not the case. But we were still able to find a solution. And this is, again, I can't reiterate it enough. This is the type of support that you get from technical assistance. We worked with the building department. We worked with the contractor. There was months and months of back and forth to make sure that this condensate drainage strategy was approved by the building department and would result in safe and a good way to dispose of that condensate without creating more water damage. Yeah. Next slide, please. So those are the common technical barriers that we see in our electrification projects. But what do you do after construction? How do you make sure that your project sees success post retrofit? Well, the first one is tenant education. You really need to ensure that residents know how to properly use, sorry, there's a typo there, properly use the new equipment. Staff trainings by contractor to ensure maintenance staff can fix new equipment and teach new residents proper operation. Preventative and ongoing maintenance contracts. I mean, if you're installing like a large variable refrigerant flow system, a large central heat pump water heater, what you can do is have, hopefully that installing contractor also offers a maintenance contract, and you can hire them to maintain your systems. These systems, especially the commercially sized systems, are very complex, and it's better to be maintained by an expert. And then you should consider monitoring larger systems, and I'll talk a little bit more about that. But like solar PV and central water heating systems, you can monitor those for performance, making sure that they're producing the electricity for that you intend for a solar PV system, and the central water heating system isn't losing efficiency for whatever reason, and is a good return on investment. Next slide, please. So TA can help support here as well. We always want to help projects see success, and even after construction, a lot of programs, including like the low income weatherization program, will provide continuing support for tenant education. We have some lessons learned on cooking demonstrations. We've done one-on-one resident trainings. We've led workshops. We've developed leave behinds for tenants. And I have a few examples of that next, but really like a resource so that they can read and learn about their new equipment. I do want to call out that this is a work in progress. So essentially, we've heard a lot of feedback that tenant education is necessary for the success of these projects. And we are trying to be better at it. And we're adding it as one of the things that we provide as technical assistance support. Next slide, please. Here's some examples of tenant leave behinds. The top one here is more like a maintenance person's leave behind. It sort of explains the different modes of the heat pump water heater. As a maintenance person, if no one engaged with you around the project, all of a sudden you have this new equipment that you've never heard of, and you are now responsible for maintaining it. And you may not understand the different modes between heat pump mode, electric resistance mode, and how that impacts utilities. And these are sort of the information that we will provide in those tenant leave behinds. I will say that in our limited experience of tenant support and tenant education, leave behinds plus tenant workshops plus one-on-ones with tenant education trainings is really like important, sort of attacking it at all angles. You shouldn't just consider one strategy for tenant education. You should be thinking about a comprehensive sort of curriculum for tenant support and tenant education. We also have contractor training requirements in our programs. So we require the contractor to train the maintenance team, but at the same time, that may not be sufficient. So we also have these additional leave behinds. And then, like I mentioned, technical assistants can provide continued support. And some programs also have translation services. So oftentimes English isn't everyone's first language. And so we recognize that, and we have ways to translate into Spanish, Cantonese, Mandarin, etc. So next slide, please. And yeah, overall, AEA is here to help. We're not the only technical assistance provider out there, but we are one of them. And ultimately, our goal is to help these communities decarbonize and do it effectively without, and part of that is, technical assistance from construction all the way through to tenant education. Next slide, please. All righty, so we just talked about doing your project, completing construction, tenant education, maintenance, a little bit of maintenance, but now I'm going to talk in more detail around operations and maintenance of all electric multifamily buildings. Next slide, please. Oh, perfect, thank you. So the myth is that all electric buildings are more expensive to operate and maintain than gas systems, but is this really true? Next slide. So as I mentioned, or really as Scott mentioned, electric appliances, especially heat pumps, are super efficient, 3 times more efficient than electric appliances, in some cases 5 times more efficient than gas appliances. And what happens when you don't properly maintain that equipment, you are going to see an increase in your utility bills because it is going to decrease efficiency. A 50% reduction in efficiency going from like 300% efficient down to 150% efficient, that is going to dramatically increase your electricity usage, and you're going to see that in your electric utility bills. However, the benefit of all electric equipment is that you're not going to run into as many dangerous issues as compared to gas. Next slide, please. So if you defer the maintenance of a gas system, you're probably not going to see a visible increase in utility costs. That's really because with a gas system, you're already starting at 60%, 80% efficient. So a reduction there isn't as substantial as a 300% efficient heat pump water heater or heat pump HVAC system. So you're probably not going to see it in your utility costs. Also, gas is pretty cheap. However, when you do not properly maintain your gas appliances, you could cause dangerous combustion safety issues. So here, this is from one of my site visits a few years ago, where we had a combustion analyzer in the wall furnace, and we're seeing carbon monoxide levels of 10,641 parts per million. Just to sort of put that in perspective, 30 parts per million for 8 hours will set your CO alarm off. This will cause CO poisoning very, very quickly. So this is a improperly maintained wall furnace that may not be showing up on your utility bills in terms of inefficiencies, but it will be showing up in dangerous issues. And of course, we have gas leaks as well. A few years ago, we went back through 1,200 dwelling units. We had gone through and did combustion safety testing in 1,200 dwelling units. And we tested 1,800 combustion appliances. And what we found is about half of them had some sort of combustion safety issue. So that's a significant amount. Next slide, please. The importance of utility monitoring, like I mentioned, your all-electric building, if you have deferred maintenance, you're going to see an increase in utility costs and an increase in utility usage. And so you should take advantage of these utility monitoring softwares that exist. If you have a complex, maybe like a high-rise building with lots of central systems, you should consider installing a building management system. And what to look for when you sign up for this monitoring software building management system is unusual spikes of energy usage. These can indicate that the system is not performing properly and it needs some maintenance. You should also, this can also inform sort of like how often you should maintain your equipment, like how often you should be changing filters, that sort of thing. Make sure you consider solar PV and changes in use based off season. Your heating usage is going to be more in the winter. And then also rates are constantly changing. Rates change between the summer and winter. You should set up alerts based off of energy usage, not cost. Next slide, please. I'm going to run through these really quickly. Heat pump HVAC and heat pump water heater overlaps. Like Scott mentioned, you have this whole refrigerant cycle. Fortunately, if you're electrifying your water heating and you're electrifying your space heating, it's the same technology. It may look very different, but what the components inside are very similar. And in terms of like how to maintain that equipment, it's also very similar. You'll have an air filter that you have to swap out. You'll have heat exchangers and coils that you may need to clean. So when you're looking at a heat pump water heater or heat pump HVAC, you're going to have very similar maintenance requirements. Next slide, please. Now, I'm not going to go too far into this, but this is just like for reference, what is required to maintain your electric HVAC versus your gas HVAC. If basically because a heat pump is just an air conditioner that can reverse, you're going to be doing the exact same maintenance for your air conditioner as you would do for a heat pump. And the only addition is if you have an air conditioner plus a gas furnace, you have all the gas maintenance stuff that you need to do. Next slide, please. For a heat pump water heater versus gas water heater, you have an air filter for your heat pump water heater. Gas water heaters, only the high efficiency ones, the 95% efficient ones, have an air filter, but that is now the federal standard. So you should be considering if you're going to install a new gas water heater, you're going to have to purchase that 95% efficient gas water heater. You're going to have an air filter as part of your replacement. And then flushing heat exchangers for hard water. Heat pump water heaters, they have really tight flow paths for water, so that can scale similar to a tankless gas water heater. Next slide, please. And then, of course, maintaining solar PV systems, similar to just your all-electric building, you should sign up for a monitoring platform. A lot of inverters have monitoring software that can be an add-on, so I would consider that for your project. And you should also incorporate visual inspections of your solar PV. So you should be monitoring how much production you have. You can compare that to previous years. You should also be doing visual inspections to know if it needs to be cleaned, if the solar panels need to be cleaned. I mean, this one on the bottom here probably needs to be replaced. It was hit by a bunch of golf balls. So things like that, visual inspections, it's pretty easy to add to your maintenance schedule. Next slide, and I think, these are just reference slides, so we can skip all of these. I think that's it for me. Thank you.
All right, thank you, Jack. Wonderful stuff there. We're gonna round it out now with a new construction case study with Erin Keller. Take it away, Erin.
Thanks, Ian, and thank you, Jack. Thanks, everyone, too, for sharing your morning with us. I'm going to wrap us up with a brief case study, and then we'll dive into some of your questions. This case study comes from the BUILD program, which is a residential new construction program that covers the state of California. The specific project that we'll be reviewing today is the Levant Senior Cottages project. This is located in San Diego, California, and it is affordable housing, but it is also specific to senior living. The developer on this project was Wakeland Housing and Development Corporation. And as you can see in the project photo, there's 10 residential buildings that cover 127 units, as well as a large community building. And this property opened up to residents in June of 2024. We completed an interview with the project team and case study last year in 2025. Overall, there was a lot of thought and consideration that was put into this project. specific for senior residents. As you'll see in the upcoming slides and all the photos of the property, it's a beautiful property, the landscaping and everything, but they also did some things like putting the patios next to each other to help facilitate some friendly neighborhood chat within the community. And one of the big considerations for their design was the fuel type. This project came to the build program originally with gas in the project, but like we heard about earlier, this project was facing some economic challenges and was looking for ways to improve their funding stack. So between build and Energy Smart Homes funds, they chose to upgrade their design to all electric and pursue those funding opportunities. This was one of the first projects for Wakeland that went all electric, and they have decided as a company that that's where they want to go. We have seen them as a repeat participant in the build program since this project. So when talking with the project team at Levant Senior Cottages, there was a handful of design priorities that they had in mind that influenced their equipment selections. First and foremost, managing their operating expenses. For this project and for other permanent supportive housing projects, Wakeland was paying the utility bills. So it was a consideration for them to keep that cost down throughout the lifetime of the project. Additionally, these again are senior residents. It was a big priority for Wakeland to support resident health as they could and improve the comfort of the seniors living in the homes. And as I mentioned, financial stability. This comes up with a lot of affordable housing projects, and specifically during the construction phase. There's a lot of variables that can be thrown at projects, whether that's weather, supply chain delays, and a bunch of other things that come up that your funding stack needs to be able to adjust to and cover. So again, they chose to pursue 2 incentive programs and change their design to all electric. So the heat pump, HVAC, and smart thermostats helped address some of the operating expenses, supporting resident health by not having internal combustion in the units. And the heat pump systems cover both heating and cooling, so residents can adjust that to their liking. With the smart thermostats, they could also set schedules and overall keep the comfort and temperature of the unit as they like it. As you could see in some of the project photos, the project also installed PV. So they were able to use that solar generation to offset their electrical use and help manage the operating expense. We heard a lot from Jack about technical assistance. Build is one of the programs that offers technical assistance to applicants. AEA is a technical assistance provider on this project. And aside from just the nitty-gritty technical aspects of the project, technical assistance can also mean help with completing your incentive application, finding program layering opportunities, coming on site and looking at equipment. So this project particularly used technical assistance for assistance with the incentive application and identifying other programs to layer funding with. So here are some of the project stats and another photo of the property. The build incentive for this project was nearly $300,000. And again, we were able to coordinate layering with the Energy Smart Homes program to get them an additional $200,000. And this was able to help the program navigate some of the challenges they faced during construction. And as far as the environmental impact for the project, they were able to save nearly 58 megatons of CO2 being put into the atmosphere. So not only were they contributing to indoor air quality for their residents, but outdoor air quality for their community. And this is a hard number for us to conceptualize, so I like to use equivalencies here. That number is equivalent to the carbon sequestered by 972 tree seedlings grown for 10 years. So this project overall contributed a lot to their community. This was a project that was very well received and one that we were happy to support through builds. Next slide, please. If you want to review the full case study when we share these slides, that is a hot link there that you can click. And I'll add to that we actually received some resident feedback on this project, and they have shared that they love their community. They have a lot of services available to them through their community center. And one quick story from this project that I thought was really cute was that the project or the property manager received a cake from one of the residents, and they thanked them for their continued support of the community. So overall, a really good, heartfelt and positive project that came through the build program. That is all I had to share with you today. And I'll pass it to Angel for answering your questions.
Yes, thank you. Thank you to all the speakers that we have for today's training series. So as we approach the end of our session one training series, we did send out currently a poll slash survey question. So while you take a look at that, we'll also be answering some Q&A. I know we have some questions that came in through the chat. I know, thank you, Scott, for actively answering in the chat. But we do have a couple remaining. So I thought maybe starting off with the first question we have here. Um, let's see. For the build case study, did they install induction cooktops and electric ovens? I believe this would be for Erin.
Yep, the build program does not require induction cooking, so this project chose not to install induction for this project. They did have a full kitchen that was electric resistance.
And I have this other question. So, when you're evaluating an existing multifamily property, what are the earliest indicators that a project is going to require a major electrical service upgrade versus being able to use more of the energy efficient equipment?
Yeah, I can take that one on. I think the number one indicator is whether the electrical infrastructure is using recalled electrical panels. Those typically need to be replaced regardless of the like lean electrification or power efficient design we use on the project. In terms of like capacity, we often try and exhaust all other strategies like load monitoring and that sort of thing to avoid electrical upgrades. But there are some units that have 30 amp disconnects, and there's really no way to sort of like finagle getting out of upgrading those. So I would say like generally the number one thing is recalled electrical panels, and then in terms of like if that's not the case, in terms of like actual capacity, we typically exhaust all avenues before we commit to an upgrade.
Thank you. I have this other question. For a property that has limited funding and can't electrify everything at once, how would you recommend prioritizing measures? So from like HVAC, water heating, cooking, the building envelope, phasing. I know there's some programs that could provide some sort of phased payments. So how would that look like?
Yeah, I think it really depends. This is like a non-answer, but property by property, right? And the motivations of the owner. If you have a central water heating system and you're interested in solar and you're interested in reducing your utility costs, then swapping that with a centrally pumped water heater and adding solar is probably going to be the first thing that we do, because that achieves your goals for the property. If you have failing HVAC equipment or a lot of combustion safety issues for your heating system, then we will prioritize HVAC. There are some measures that we want to combine with one another. Like say if you're installing new HVAC and you have to open up walls to run refrigerant lines and circuits, we should be insulating those walls while we do that. So there are some measures that sort of complement one another and should be done at the same time. Different incentive programs pay different amounts for different measures. And so depending on the incentive program and your available reserves, there might be a way to creatively phase the project to alleviate cash flow issues. So yeah, again,
Mhm.
kind of a non-answer, but it depends.
Yeah. Yeah, with these programs, I always like to kind of picture like you're going to like a market, you see all these cereal brands. That's what it is with programs in California. They all have different eligibility requirements. They all offer different measure upgrades. So it really depends on what is exactly that you're looking for. But yeah, I mean, the good thing is that we have a wide subset of different programs to choose from. Let's see. There's this other program. This other question. Will these slides be available after? Yeah, so the slides and the recording will be available after our session. So you'll see those up as well. Um, yeah, and it looks like we don't have any other questions. Um, okay, we could probably move on to the next slide. And thank you for everybody who submitted a response with the poll questions. We really appreciate it. This will help us further review on the overall training and see how we can better improve for our next sessions and next year. But yeah, just to quickly recap, we do have session two coming up. This is this upcoming Tuesday, and this session will be focused on making electrification pencil, so funding, utility allowances, and scope strategy. So we do have a great set of speakers for this session. So we hope you can join us and learn more about the different funding incentives, phasing out the scope, utility allowances. I know that's a hot take, and then heat pumps and the pathways. So we hope you can see us there. And if you have any questions, feel free to contact us at sustainability at calhousingpartnership.org. I know it looks fairly small in that font, but we are here as a resource to you to help start your retrofit and overall rebate process for your projects and your portfolio. And with that being said, we'd like to thank everybody for joining us today. If any questions come up, definitely feel free to shoot us an email. I want to thank our presenters for coming in today and speaking on their expertise on electrification, decarbonization. So without further ado, I hope everybody has a great day and we hope to see you on Tuesday.
Thank you all.